Gathering weather data. Two important factors in weather forecasting are the accuracy of the data and the amount of available data. Now, there's four things that are usually found in a forecast. The temperature, which is measured by a thermometer, the air pressure, which they use a barometer to measure, the wind speed, which is measured by an anemometer, and the relative humidity, which is measured by a hygrometer. Now, I found this nice little app that gives you all of this information. It gives you the date, it gives you the time, the temperature, gives you short-term and long-term forecast. It also then gives you a key so you can see what you're looking at. And then it gives the wind speed right there, 14 miles per hour, wind chill, wind direction. It gives you how much precipitation, when it's going to precipitate, and such. It is a very good model to use. Now, in this table, we're going to compare the different types of instruments that measure, what they measure, and how they work. We're going to start with a barometer that works by measuring the changes in pressure measured by the changes in height of a column of mercury. High pressure air will push the mercury more, low pressure air will allow the mercury to go down, which then you have low pressure. Now, barometers measure air pressure. The next one that's listed is an anemometer, and an anemometer measures wind speed. And how does it work? It uses cupped arms that rotate as the wind blows and gives you the speed of the wind. A hygrometer uses a wet and dry bulb thermometers and compares their temperature to give you the relative humidity. Now, the only one that's left that we mentioned on the previous slide was a thermometer, which measures temperature. And how does it work? There's either mercury or alcohol expanding when it's warmed, and that is how they get the temperature.
I'm sure you've probably heard the term Doppler before, but did you know the principles that we use in our weather radar today was developed more than 150 years ago by an Austrian physicist named Christian Doppler? He found that the occurrence produced by a moving source of waves in which there is an obvious shift upward in the frequency for observers towards whom the source is approaching and an obvious shift downward in the frequency for people for whom the source is moving away. Okay, let's simplify the Doppler effect for you. Think of a car on a road honking its horn. While the car is traveling towards you, you can hear the high-pitched sound of the horn. But suddenly, after it passes by, the pitch lowers and drops. Now, this is a perfect example of the Doppler effect, and this is how it's used in weather radar. The radar sends out a pulse of energy, which then reflects off an object, such as a raindrop. Now, some of the energy reflects away into the air, but the majority of it goes back to the radar, where it then calculates how far away the raindrop is, how intense the rain is, and which way the raindrop is moving in relation to the fixed radar site. Now that is where the Doppler effect comes in. We use the data sent from the most powerful radar in East Tennessee at the National Weather Service office in Morristown to our Storm Tracker 6 computer to show you the rain, sleet, and snow. But during severe weather situations, the wind speed and direction is what is the most important. If the wind in a small space is going away from the radar in one area and towards the radar right next to it, this can show that there's rotation within the storm, and that means there's a possibility that that storm could produce a tornado. Now, it can also show how strong winds are over a given length of a line of storms, and this can help determine whether the storm could produce what we call straight line winds. With Storm Tracker 6, we also have access to all the National Weather Service Doppler radars across the country, including Nashville, northern Alabama, southeast Kentucky, and northern Georgia, to give you the most complete storm coverage in East Tennessee.
The Automated Surface Observing System, also called ASOS, gathers data in a consistent manner 24 hours a day, every day. It provides essential weather data for aviation, weather forecasting, and weather-related research. The instrument used to gather upper atmosphere data is called a radiosonde. A radiosonde sensor measures temperature, pressure, and humidity, so everything except for wind speed. A weather radar detects specific locations of precipitation. The Doppler effect is the change in pitch or frequency that occurs due to the relative motion of a wave such as sound or light as it comes toward or goes away from an observer. So analysis of a Doppler radar will give data that can be used to determine the speed at which the precipitation moves toward or away from the radar station. Upper level weather data is collected by a radiosonde, which is a series of sensors carried by a weather balloon. Sensors that measure temperature, air pressure, and humidity are carried. Measurements are sent back by radio signal. Tracking is very important when measuring upper level data because it helps determine the wind speed and direction. Now, the way a weather radar works, the first thing is we need to figure out what is going on first before the wave bounces off large raindrops. Well, the first thing that happens is a transmitter generates electromagnetic waves. Those waves then bounce off of large raindrops, and after they bounce off of raindrops, the echoes are received by the antenna. The amplifier increases the signal of the scattered waves, computer processes it and displays them on a screen, and the meteorologist can then locate the raindrops. Some weather satellites use infrared imagery to make observations at night. Objects radiate thermal energy at slightly different frequencies. Infrared imagery detects these different frequencies, which enables meteorologists to map either cloud cover or surface temperature. Another type of satellite imagery that is used in weather analysis and forecasting is called water vapor imagery. Water vapor imagery is a valuable tool for weather analysis and prediction because it shows moisture in the atmosphere, not just cloud patterns. Visible and infrared imagery. Colorized infrared imagery. Same map using something different. First was what it looks like. Second is the heat that's being generated. Water vapor imagery. Same map, just using a different technology, and each time you can see that a hurricane is hitting Texas. Organize information about weather data collection for precipitation tracking by completing the graphic organizer. Scientists can determine the location of precipitation in clouds using a radar or satellites. A radar tracks precipitation, where a satellite tracks clouds. Infrared imagery can be used by data collected in darkness, so you can do it at nighttime. Infrared imagery detects differences in thermal energy, so that's heat transfer. Objects show up differently according to their heat that they emit, so you get different colors due to the different heats that they have. The temperature of a cloud tells meteorologists its type and height. Section 4. Surface weather analysis. Station models. A station model is a record of weather data for a particular site at a particular time. Meteorologists use symbols to represent weather data in the station model, and the symbols you can see in the table to the right. To plot data nationwide and globally, meteorologists use lines that contain points of equal or constant values. The lines of equal pressure are called isobars. Lines of equal temperature are called isotherms, because iso means to isolate. Isoplests are broken down into isotherms and isobars. Isotherms are lines of equal temperature, and they identify the temperature gradient, just like in a topography map. And an isobar, which indicates how fast winds are blowing, uses lines of equal pressure. Depending on how close those lines are or how far they're spread apart, that will then indicate how fast the wind's going to blow. So usually if you have isobars of different pressures and they're very close, you're going to get much faster wind than isobars that are spread out. The weather map shows isobars and air pressure data for the continental United States. Using isobars, isotherms, and station model data, meteorologists can analyze the current weather conditions for a particular location. Types of forecasts. A digital forecast is created by applying physical principles and mathematics to atmospheric variables and then making a prediction about how these variables will change over time. An analog forecast is based on comparison of current weather patterns to similar weather patterns from the past. A short-term forecast is the most accurate and detailed forecast because the weather systems change directions, speeds, and intensities over time. So if it's short-term, you're going to get it over a short period of time versus a long-term forecast because it's impossible for computers to model every variable that affects the weather at a given time and place. All long-term forecasts are less reliable than a short-term forecast. Compare and contrast short-term forecasting and long-term forecasting. Discuss reliability, techniques used, and the type of information that's gathered. So short-term is more reliable. It uses extrapolation and the behavior of large surface and upper-level features, and the temperature and amount of precipitation. So this would be like a daily forecast, where long-term forecasting is less reliable. So if you're watching the TV news and they tell you that next Sunday it's supposed to be a certain temperature and a certain weather pattern, that can change because if you're looking at this 5 or 6 days in the future, it's not going to be able to say that everything that they do model-wise is going to come true. It uses circulation patterns in the troposphere and the lower atmosphere of the stratosphere, and it estimates weather. So short-term forecasting would be like a daily forecast, where long-term forecasting would be more of a weekly forecast. The factors that cause the accuracy to decline with time. And this is why people always say, well, the weatherman's only correct half the time. Well, the first thing is things like mountains, valleys, rivers, lakes, cities affect the amount of heat absorbed. Second thing is this affects the pressure and therefore the wind in that area, which then affects the cloud formation and all other aspects of weather. That's why if you watch a Philadelphia news weather, you will see that their weather is a little bit different than it is here in the Lehigh Valley because we have less buildings and we have more terrain